Today we are going to continue lecture for circular motion. In the last lecture we have studied about linear velocity, direction of linear velocity, angular displacement and angular velocity. Today we are going to discuss next topics of the circular motion. Let's start with angular acceleration. What is angular acceleration? It is the rate of change of angular velocity, that is d omega by dt. Angular acceleration is simply rate of change of angular velocity. We can also represent it at delta t tends to 0, delta omega upon delta t. So this is instantaneous angular acceleration. So angular acceleration, by formula we can write angular velocity upon time. SI unit of angular velocity is radian per second. Again, this is time second, so second square. So SI unit of linear acceleration is meter per second square. SI unit of angular acceleration is radian per second square, and we can write the dimension of angular acceleration as t minus 2. This is time square. Okay, radian is dimensionless, so angular acceleration is rate of change of angular velocity. Now angular acceleration is a vector quantity. Then how can we represent direction? We can represent direction again by right hand thumb rule, as we have seen it previously in our first lecture of circular motion, right hand rule. So angular acceleration is a vector quantity. We can represent it by its direction by right hand rule. But here one thing we have to remember is that suppose that an object is moving along a circumference of a circle in anti-clockwise direction, say. In this case, this is axis of the circular path. This is angular displacement, this is angular velocity, and this is angular acceleration. Now here one thing is important. If omega bar is increasing, if omega bar, that is angular velocity, is increasing, then angular acceleration is in the same direction as that of the angular velocity. So if angular velocity is upward, then angular acceleration is also directed upwards. But if angular acceleration is decreasing, if angular acceleration is decreasing, then direction of angular acceleration, if angular velocity is decreasing, then direction of angular acceleration will be opposite to the direction of angular velocity. We can say it as a retarding, because in accelerating mode velocity increases and in retarding mode velocity decreases. Velocity decreases, it means that acceleration is opposing the velocity. So angular velocity when increases, it is in the same direction of the angular acceleration. And when angular velocity decreases, angular velocity and angular acceleration are oppositely directed. This is one of the important topic of the circular motion. So angular acceleration. So angular velocity, angular acceleration, we have seen different formulas. Angular displacement, theta is equal to arc upon radius. Then angular velocity is limit delta t tends to 0, delta theta upon delta t. Then angular acceleration, this is d theta by dt, and angular acceleration d omega by dt. We have seen all those different formulas. This is arc AB and it delta s upon radius r. Relation between linear displacement and angular displacement, that is the delta s bar, can be written as delta theta bar cross r bar. We simply write delta s is equal to r delta theta in scalar format. But in vector format, we have to remember this particular notation. Delta s bar is equal to delta theta bar cross r bar. Then linear velocity and angular velocity relation, v bar is equal to omega bar cross r bar. Relation between linear velocity and angular velocity, v bar is equal to omega bar cross r bar. In simple notation, we can write in scalar format, v is equal to r omega. As omega is 2 pi upon t, we can write in this way, 2 pi r upon t. And 1 upon t is frequency, so we can write 2 pi rf. So linear velocity relation V bar is equal to omega bar cross R bar. V is equal to R omega. Omega is 2 pi upon T, that is period. 1 upon T is frequency. Third one, linear acceleration or tangential acceleration in circular motion. It is equal to angular acceleration into radius vector. Tangential acceleration is angular acceleration into radius vector. So these are the basic important things you have to remember carefully. Tangential acceleration in circular motion is alpha bar cross R bar. So these are very important formulae here. So we can write tangential acceleration in scalar format R alpha only.